Hi, and welcome to Quick Add Maths on permutations and combinations. Before we get there, let's understand the concept of factorial. Factorial is represented by the exclamation symbol. And in the case of 4 factorial, which is written as 4 exclamation, it is equal to 4 times 3 times 2 times 1. In a similar manner, 5 factorial is equal to 5 exclamation, which equates to 5 times 4 times 3 times 2 times 1, and so on. How and where is a factorial used? As an example, when we are asked to solve 7 factorial divided by 4 factorial without the use of a calculator, it equates to 7 times 6 times 5, as its 4 times 3 times 2 times 1 has been cancelled out. What is observed from the above is when the product of a series of subsequent integers is represented, it can be simplified with the use of the factorial notation. A further example shows that 100 times 101 times 102 can be written as 102 factorial divided by 99 factorial. Next, when a total of n different objects are subjected to an arrangement, the number of possible different arrangements is n factorial. Example 1 shows the total number of arrangements for the numbers 1, 2, and 3 is 3 factorial, which comes to 6. And all the possible arrangements are 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. Example 2 shows when 3 different alphabets and 4 different numbers A, B, C, 1, 2, 3, 4 are arranged with the criteria that all alphabets must come first, state the number of possible arrangements. In this case, the required number of arrangements is the product of 3 factorial and 4 factorial, which comes to 144. The two independent arrangements will multiply because each alphabet arrangement can be subjected to all possible number arrangements. Tutorial question 1. 5 digits 2, 3, 4, 5, and 6 are arranged to form a 5-digit number exceeding 20,000. How many different arrangements are possible? This would be 5 factorial, which comes to 120. Next, how many different even number arrangements are possible? This would be 3 times 4 factorial because the last number can only be 2, 4, or 6. Next, how many different arrangements above 40,000 are possible? This is 3 times 4 factorial because the first number can only be 4, 5, or 6. Next, how many different arrangements above 40,000 that are even are possible? With the number of possible fixed first and last digits being 7, namely starting with 4 and ending with 2, starting with 4 and ending with 6, starting with 5 and ending with 2, starting with 5 ending with 4, starting with 5 ending with 6, starting with 6 ending with 2, and starting with 6 ending with 4, the possibilities are 7 times 3 factorial, which comes to 42. Next, in permutations, when a total of n different objects are subjected to an arrangement, but you would only arrange to the quantity of r where r is less than n, npr is equal to n factorial divided by n minus r factorial. As an example, the total number of arrangements for the numbers 1, 2, 3, 4, 5 to form a 2-digit number is 5p2, which is 5 factorial divided by 5 minus 2 factorial. This comes to 20, and all the possible arrangements are as attached. Let's do a tutorial question on this. 8 athletes from 8 different countries A, B, C, D, E, F, G, H are competing for the gold, silver, and bronze medal. What are the odds that A will win the gold, B the silver, and C, the bronze, assuming all the athletes are equally capable. Here, its permutation is 8p3, which calculates to being 336. This takes the odds to 1 out of 336. Combinations apply when the arrangement is not important. It is written as NCR and equates to n factorial divided by r factorial n minus r factorial. As an example, when 8 athletes from 8 different countries, A, B, C, D, E, F, G, H, are competing for the gold, silver, and bronze medal, what are the odds that A, B, and C are awarded with medals, assuming all the athletes are equally capable? When the arrangement is not important, it is 8C3, which comes to 56. Therefore, the odds here is 1 over 56. Tutorial question 3. 6 students have stopped 2 taxis. Each taxi can only house 3 people. Find the total number of ways in which the 6 people can be distributed across 2 taxis. For the question, its combination is 6C3, which works out to being 20. In this case, the arrangement of the second taxi is not important. This video has covered the very basic on permutations and combinations. To have a good grasp over the subject, you must proceed with running through the video on Arithmetic EQ on permutations and combinations. Have added the link to the said video here, so do get on board this video to help with mastering the subject. Go, go, go!